Hi people, this is the third video segment that I'm making for design table for an assembly. Now, this problem that you see here is a little bit harder than the other ones that we have done because the shape of this, that wedge-like shape, makes it a bit of a hassle trying to put these things together. Okay, eventually, of course, I'm going to use this design table like that. But let's go and make the nominal product, which has the nominal parts in it. Okay, so let us start with a Catia program and a product structure, and then immediately save it. File, save management, save as, desktop, new folder, problem 3 assembly. Okay, everything is going to go there. And save it. Okay, then I'm going to insert my first part, insert a new part in there. First I'm going to do the block, right click, properties. This is the part name, block. This is the part instance, so also I'll call it block. And let's go make it. So double click on this so that you go into part design and you make it. On that vertical plane, I will sketch a rectangle. I'm not claiming this way of doing the problem is the easiest one. I'll let you worry about it. So if you have other ways of doing it. So this is going to be, eventually this is going to be, because we have a block, all the sides are the same, so we need to dimension. Of course, these are all going to be the same at the end. Exit, pad it, and I'm going to do it in the other direction, no particular reason. So I'll put 4 so that these are roughly the same size. Okay, good. And then on that face, I will sketch. A triangle, and I'm going to clean it up in a minute, like so. Okay, let's clean it up. So this control that, coincidence, and this control that, also coincidence. I hope you see where we're going with this. Exit. Oops, I don't think it did it. So this control that, coincidence. All right, exit. Oh, this is going to be my W, and this angle is going to be my beta. So why don't I put this dimension here right now? This is going to be eventually W, and this angle is going to be eventually beta. Exit. All right. Now I'm going to create a point on that edge, and then a plane through that line and that point, and then split this block. So on a curve, create a point on a curve, and the curve is right here. Okay, something like that. The location of it doesn't matter. Eventually, we have to parameterize this. So a plane through a point and a line right up. A point and a line. So the point is right there, and the line is right there. This is the inclined plane that you see here. And then we're going to split it. Split is right here in the surface space feature. Split with that, and the direction of the arrow is the direction that you want to keep. I flip this thing so it keeps that side for me. Very good. Why don't we apply material while we are at it here? Apply material, aluminum on this line. This line, remember, not that line, this line, because we want it to go on part, not on the assembly. And then we say OK. You can see that right there. Now we're going to make the other side, the other piece. So by the way, save this thing. Go to the assembly level and click on the do the product and the part. So insert a new part in there. Say no, and I'm going to call this thing the wedge. Right click, properties. There is your wedge, and there is your wedge. Okay, let's go make it. Double click on the edge. Sorry, I meant wedge. Right click properties. I thought I said wedge. I'm not sure why it was saying edge, because let's try it one more time. Yeah, it says wedge. Let me type this thing again. For some reason, it doesn't like the wedge. Oh, I don't know. Let's move on. That's not important. Should have been wedge. Okay, so let's go to the part design. We are in part design on a convenient plane, on that same vertical plane. YZ. I'm gonna sketch. Okay, the profile, which looks like this. Dimension it. So dimension this edge. Eventually that's going to become W, and this angle, which is eventually going to become the same angle that you see on the left side. Exit. Pad it in the other direction. Let's go further there. And our strategy is the same thing. We make a point here, and then we create a plane and cut it. So a point on a curve, on this curve. For some reason I can't move. Maybe. Okay, actually, let me say 3. See what happens. That's too far. I don't want to go there. Where is this point? Let's go to 2. Better. And then create a plane. Point on line. Through point on line. There's the point. Not the face. Try it again. Sorry. A point. Plane through the point and line. Point and line. So the point is here, and the line is there, and we say OK, and we're going to split it, and we keep the side that you see right there. Okay, this eventually has to fit in there tight and nicely. Okay, so apply material, some dummy property, brass on that part, and we say OK. Good. Yeah. Okay. Now, save everything. Go to assembly level. There's the assembly level. See the two gears here. Okay, the next step in our problems of design table was renaming. Okay, and if necessary, putting equation. If there are any equations. So let's first of all, let's go and make sure that we can make this thing a true block. Okay, so click on f of x. First of all, make sure that you are at the assembly level, and click on f of x, and then click on the product. So anything that you need is gonna appear here. For example, this guy, I'm gonna call it L. So I'm gonna call it L. Apply. All right. This guy is going to be equal to L. So add a formula equal to L. Good. This distance, which is the padded length, is also L. So you select that. Add a formula also equal to L. Okay. Now, if I update, this is going to become a nice block. We'll see. There. It's a nice block. All sides are the same. All right. Now, this height is going to be the same as the height that you see over here. Okay. This is going to be W. I'm going to call this thing to be W. So you select that, and I'm going to call it W. Apply. Now this guy is equal to W. So add a formula, rename parameter W. Very good. If I say OK, these two will become the same height. Or actually, if I update, they become the same height. This angle is what I call beta. So I call this thing beta. Apply. And the angle here, this angle is equal to beta. Add a formula, rename parameter beta. Okay, good. If I update, these become the same angle. Now, the other thing that I want to do is this length. See that length? This is the position, the coordinate of that point in that direction. So this is what we call H. Just look at your diagram. This is your H. Okay? So that guy, I'm going to call it H. Apply. And this guy is equal to that guy, which is equal to H. Add a formula, rename parameter, H. These are the same length. We are pretty much done. The only thing is that if you want, you can also rename. You can also rename the part names and the material and things like that. But I'm not going to do that. I'm going to do it a different way. We say OK. All right. So now we're going to go to design table. Make sure you're at the assembly level. See that? You are at the assembly level. 2 gears. Design table. Okay. We're going to create it. Say OK. It says, what do you want to put in it? Well, definitely I want to put those renamed stuff. So let me see for a second. Where's all that renamed stuff? Definitely these are going to go there. Okay, but I also want to put the part names and material. So back to all. Now, because I did not rename those things, they're not appearing in my renamed list. So I have to go find it basically. So let's go find the part number for the block. Well, first of all, here is the block material. I'm going to send it there. Then look at part number for the block. Let's see if we can find it. Part number right there. Send it there. And we also want the stuff for the wedge. So wedge material right there. Wedge material. Send it there. And wedge part number. Wedge part number. Wedge. Where is it? Right there. So what's going to happen in my Excel spreadsheet, these are the things that are going to appear. And we say, OK, it says, where do you want to put it? Now, I think I had problem 3 assembly. It's there. So we say save. Good. You can see that. Now, edit table. The only thing that I don't like here is look at the order of these things. See the order. These are L, W, beta. I want, for example, if I want these guys to be in the first 4 columns, what you need to do, you go there, click on the association table. See that? This was the configuration, association, and you can move these things up or down. For example, if I go to the block number right there, move it up, 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 and then block material up, up, up to the location that I want, and then wedge part number. Remember I said that you can rearrange the columns, but we never had to do that because the order that we selected these things was in the previous step. Okay, good. So if I go to the configuration, now you can see part number, block material, wedge number, block, wedge material, etc. And these are, of course, the dimensions that I want. These are numbers, angles. Okay, so we go to edit table. And you're familiar with this thing, so let's right. Now, you just have to be a little bit careful here because the spreadsheet, when you look at the spreadsheet, the position of these things are not the same. So you have to be a little bit careful. For example, L, I'm going to make it 6. W is that height, I'm going to make it 3. Beta, I'll make it 45 degrees. H is this. Oops, where is that? Where is my Excel? H, I'm going to make it 2. This is out of gold. I'm going to make it out of gold. The name of it, I'll call it my block. My block. Let me give it, call it B001. How about that? And this is for the wedge. I'll make it iron. And this is the name, so I'll call it W standing for wedge 001. Let's do one more row. So for example, the block length, I'll make it 8. The block W is that height that you see there, is going to make it 5. The angle beta, I'll make it, I don't know, maybe 20 degrees. Okay. H, I'll make it, okay, so how about making it, well, it has to be less than 8 for sure. So let's make it 7. Material, steel. Name of it is B002. For the wedge, make it the copper. And the name of it W002. We save this thing. We close it. All right. So for example, let's try this. When you select the second row and update, see, exactly the same size. They fit. Next one, update. Okay, so there is a problem. There is a problem with that length. Okay, so must have done something that is not quite right here in one of my equations. Let's see what I did in the equation. This first one, let's try the first one. Oh, you know what? When I padded this guy, I don't think I padded it long enough. Okay, so let's let me go to first one, apply. Okay, that's all right. Let me close this. I'm going to go to this piece. I'm going to go to this piece, which was the pad. The length of that pad is not long enough. This is why I don't think it goes past a certain point. So let's go back here. Instead of 2, let me make that pad, I don't know, 8. All right. So now let's go back and try to look at the design table. Minimize this. Okay. Obviously, the first one is the nominal one. No problem. It's going to work. Where are we here? Okay, I'm not in assembly design, so the update is on the right side. There it is. No problem. Double click. Design table. The second one was working. Apply. Update. Right there. The third one which was not working before, better work now. Apply and update. Yep. You see that? When I created this part, I padded by 2, not long enough to accommodate the rest of the problem. Now, in order for you to get full grade on a problem like this, you have to put assembly constraints on it. And what do I mean by that? Let me hide the stuff that I don't want. Oops, cancel. Hide this. Just so that we can see it better. I want to hide it. That's all I want to do. Hide. There. Okay, good. Now, what do I mean by putting constraint to get full mark? Let me hide the tree first. For example, well, first of all, you have to be an assembly design, and I'm not. So let me go to assembly design. I'm gonna create a coincidence between this face and that face. Coincidence between this edge and that edge. And coincidence between this edge and that edge. And just to be on the safe side, I think this will do it. But yeah, this will do it. If I update, they're going to go back to it. Now, when I move this thing, when I move these things, rotate, do all kind of weird things, when I update, it should go back to where it was. If it doesn't, I need more assembly constraints. And there we are. This will give you full mark. Otherwise, you lose some marks for the fact that the assembly constraints are not maintained. And that will